Alright, so I'm back in the car, driving to the house. It's kind of weird saying that considering I'm between houses now. Moving between. And so I wanted to talk about how fogged up my window is. I'm kidding, I just now noticed that it was fogged up, and there's really nothing I can do about it. So maybe turn the AC up a bit. It's really cold on top of that, so anyway. So my last video I talked about science fiction and physics. I talked about how in shows like, Star Trek, Star Wars, Battlestar Galactica and whatnot, physics tends to take a back seat. Except in Battlestar Galactica, that's a different story. And, honestly, I was watching a video about Star Wars where they were talking about the speed difference between the Millennium Falcon and the Prometheus from Star Trek. The Millennium Falcon from Star Wars and the Prometheus from Star Trek. And if you don't know what the Prometheus is, and you've only seen a few episodes of Star Trek, or if you have seen a lot but you don't know which ship that is, the Prometheus is an experimental combat ship, multi-vector combat ship. And in Star Trek, what they mean by multi-vector is coming in from different angles, multiple angles. How does a ship come in from multiple angles? Well, the Prometheus, which had a warp factor speed of 9.99, or maybe it was 9.8, was capable of also separating into 3 separate ships. Not only could it do that and essentially attack multiple targets or the same target from multiple vectors, and each one had, its own independent shields and other stuff, and I'm pretty sure they each had warp drives. So the Prometheus could also separate while in warp. Something that I thought you couldn't do. I thought that was a no-no. But in Star Trek Voyager, they show the Prometheus clearly separating into its 3 separate segments in warp. And slowly drift apart from each other, and then while maintaining speed and bearing. And they were able to stay at a certain range of each other in the same warp field. So, anyway, you should all know the Millennium Falcon. So I'm not going to describe it. Based on the calculations that were made in this particular video, the Millennium Falcon is significantly faster than any ship from Star Trek, which would mean that if a ship in Star Wars, like the Millennium Falcon, was able to outrun a military combat ship in Star Trek, which was explicitly designed to be the fastest ship in the fleet and the most advanced ship in the fleet, then one would stand to argue that the ships in Star Wars would all be inherently faster than the ones from Star Trek. Kind of a funny thing to start off with, first 5 minutes there. But anyway, now, I was talking about physics before in the sense of Newtonian physics and orbital mechanics. Orbital mechanics, very interesting thing. It's basically how planets move, and how things move around planets, and how planets move around stars, and how stars move, etc., etc. But where that's interesting is, when you consider the orbital mechanics of something like a satellite going around Earth. Some satellites go around Earth every 90 minutes. Some satellites never go around Earth. What do I mean by that? I mean that it's in a geosynchronous orbit. When something is in a geosynchronous orbit, that means that it is in sync with the orbit of our planet, which means that it is rotating. It is going around the planet at the same speed that the planet is rotating. Which means that it never leaves that spot. Now, to achieve such a velocity, you would have to get further and further away from the planet, but within the planet's gravity. Just far enough. So, what I want to do is bring in something like a video game into the conversation. That's what I do. It's video games. So, Kerbal Space Program, pretty much, or quite literally, one of, to me, and for all I know it is, the most realistic space simulator that you can play as a game. And not just space simulator. I'm going to call this a NASA simulator. The reason I call this a NASA simulator is because, I really don't. I'm just using that term right now because it's funny. Is because you are literally running, operating your own space program in Kerbal Space Program. You are the director of a space program, which you not only upgrade the buildings and, build new facilities and upgrade them, but you also are in charge of developing the rockets, space planes, rovers, airplanes, boats, whatever, typically just the rockets and space planes, to get off the surface of the planet. And hold on just a second here. And the game follows a realistic orbital mechanics system. So what that means is, to put it plainly, Kerbin, the planet that you're on, rotates. And it has its own gravity field. The moon is the first moon. It goes around Kerbin, and it has its own spin, and it has its own gravity. And then there's Minmus, which is another moon, which has a very weak gravity compared to the moon. And it follows a different orbit around Kerbin, and it has its own spin. And so Kerbin, with its two moons, spins around Kerbal. Kerbal is the star. Or I think it's Kerbal. Or anyway. And then you have other planets. Elu, Dres, Duna. Duna is basically Mars, to put it bluntly. Duna is Mars. So, using Duna as an example, Duna has its own rotation, moons, whatever, and is significantly further away from the star than Kerbin. And it's up to you to find a way to get to all of these planets while obeying physics. You gotta get to Duna by calculating the right trajectory to exit the Kerbin system, or the Kerbin gravity field, to transfer to Duna. So you have to make sure that you're going the right speed and have the right amount of fuel to get there. Whether you plan on coming back or not is a different story. You have to make sure that you carry enough fuel, or that you make it so that everything that you bring can be refueled. And then do what I like to do, which is, well, I've never gotten to Duna. I've gotten to some of the other planets. But what I like to do is send another mission. Send a drone, a probe with, some science equipment that you weren't able to send the first time. Maybe split your mission into two pieces. A primary with your astronauts on it, and all the fuel and whatever they need, along with the some of the science experiments that you can send, and then send a secondary mission as a probe and have some of the other science experiments and have a lot more fuel, like double up on the fuel on the probe. So basically you want fuel to be able to get there, but then double the amount of fuel that you had on each craft to get back. Then you do an in-flight refueling via docking and go on ahead from there. Or you can do what some people do, build a massive spaceship in space and then send up multiple reusable refueling vehicles. That's my thing. I like reusability in the Kerbal Space Program. They don't have to land like SpaceX. They just have to come back down and not blow up. I mean, I try to land them, but whatever. So, probably thinking, that sounds difficult. It is. It is. It really is. There are a lot of charts, maps, and websites and stuff all over the place that'll tell you at what angle you need to be from Duna in terms of the degree that if you were to look at it from straight down from Kerbin to the star to Duna, what angle you need to be at. And when you need to be able to leave your system, at what angle. So, some very kind of sort of maybe, important specific things on how to leave the system. I could not see for a second because that blinded me. High beams. Anyway, so, there's a green light ahead too, and I'm not going to make it. That's sad. Oh well. So your first real problem is not getting your super expensive, extremely involved project off to Duna. Your real issue is getting it into space. See, that is the true struggle right there. Is getting the ship that you're building into space. Which is why a lot of people resort to sending it up in sections. And then docking them together to build a larger ship. What I tried to do once, and it worked really nicely, except I had a lot of mods that were conflicting and the game crashed because it didn't like it. What I did was I sent up my space station at a particular altitude, and it was loaded with fuel. I had two space stations. I had a low altitude space station that was essentially a refueling rig for everything to dock with before going anywhere else. And what I did was I would go on ahead, dock with it, and what I did was I turned it into a shipyard, basically. I created a strut, or a set of struts that went out away from the station a little further. And it was also, on top of everything else, it was also the most stable platform to build on in space. Instead of just building it in orbit, this station was so stable that you could dock things with it and it really not budge, mostly because of how much it weighed. And how many thrusters, or how many reaction control thrusters it had all over it. Like, I designed it to not move, essentially. And the AI on board was designed to make it stay not moving in terms of, rotation. And so what I did was I created this set of struts that I launched to build a little off to the side. Not much at all. And I would dock with the station. I had struts going in both directions, and what I would do is I would dock with the station on one side, and then use drones or whatever I had on board to transfer that segment over to the other strut on the other side of the station where I was actually doing the construction. So I would get it there, I would dock with it, I would make sure everything was stable and not wobbling around, and then I would go on ahead and transfer it over, dock it, do whatever extra things needed to be done. That other strut on the other side was holding the middle, what was to be the middle, the heaviest central part of my mission in place. And then I would build on either side of it going away and outward. So it was designed specifically to build off of that midsection that was just docked. So I would dock and move on from there. Might have been a little bit of work, but a lot of people do it. But what I would do is the launch vehicle that I would send would, it was a shuttle of some kind. Not really a shuttle. It was an SSTO or it was a rocket or whatever that had a few attachments on it that I would use drones to remove the sections that I was bringing up off of it, and then attach them to where they're supposed to go, and then they would return, grab the next section and bring it over, which is why I would dock on the other side so that I had a stable platform to grab things from. Instead of trying to float things from one thing to another, I would just grab from one side and pull it to the other. But you have to remember, you're doing all of this in space. It's not as simple as in Star Trek where they say, or even in Star Wars. Well, actually in Star Trek they do show that it is difficult. So let's say Star Wars, where they just grab something and say, all right, well, we're going to go over here with it, or we're just going to fly on over here and it won't be a big deal. Well, it kind of sort of is. Because both you and the object that you're moving things off of, the station, are moving in space. And once you undock from the station, you are now moving away from it at a different speed, in a different direction, while still going around the planet at roughly the same velocity, roughly. So now you have to slow down, bring yourself to the same velocity as the station, and go from there. And what you're then going to be doing is grabbing the section that you're going after, pulling it off the station, dealing with the same corrections that you just had to fix. Make sure that you're going the same speed, using the reaction control system to move forward, backward, up, down, left, right, however you need to. And then go in to the other side, transfer over to the other side. See, you can move in different directions at the same time in space. So while you're still going the exact same velocity as the station, you can still translate to the left, right, up, or down and rotate while going the same speed as the space station. So then you attach to the other side, undock, go to the other side, dock, undock with the section that you came for, and wash, rinse, repeat. You get the picture. It's all very complex, but I try to put it as simple as possible. And I'm pretty sure a lot of people hearing this already know this. But I would rather explain it away. Well, folks, I'm going to cut it here for now. We will come back with another video at another time. And I'm going to go say bye for now.